Selamat pagi. Good morning. Thank you for the opportunity to speak here, and I will actually continue on the presentation of Keith Godfrey. And with a background in mind of this developmental origins of health and disease concept, I will focus now on a healthy weight and probably also on obesity. So early growth and life course metabolic health. And the story actually begins in this publication from the New England Journal of Medicine, almost 50 years ago now, actually showing an observational data set that being exposed to the Dutch famine in the 40s, 45, the last century, in the Netherlands, during fetal life, actually during early fetal life, is related to a higher risk of obesity in young adulthood. And this is actually a long time before David Barker and Keith Godfrey's team came up with the other studies. This is already an important observation suggesting that early fetal life, especially early fetal life, is important for health across the life course. And during this presentation, I will focus on healthy weight trajectories. And I focus specifically on the preconception, pregnancy, and early childhood periods. And you can see all kinds of layers of factors related to these weight trajectories. And of course, these have been discussed in the past days also. When I prepared this presentation in the last days, of course, I looked up actually how big is this problem in especially this region of the world. In Western countries, I know I'm comfortable with that, to saying that it's a big problem. Obesity in childhood is a very important, I think, to be honest, the most important public health challenge that we need to tackle right now. But to be honest, when I traveled through Indonesia, I wondered, is it really a problem in this part of the country? So I looked up in the data, and this is a publication from The Lancet, the NCD Risk Factor Collaboration, published this year. And it shows actually it's very difficult to see. That's why I summarized the results from Indonesia on the slide. That Indonesia has an underweight percentage of 11%, and 8% is obese. Not sure whether you recognize these numbers, but that's actually coming from the data used for this study. In this region, Brunei has the highest prevalence of either underweight and overweight. And clearly, when you see this picture, you can see two circles, the first one from 1990 and the second one from the last years. You can see a very steep increase looking at the blue and the purple figures on the slide. They are much higher, of course. So the percentage has increased. And actually, look up this paper. It's too much to discuss it right now. But the orange part on the slide is from the Southeast Asian region. So the problem of overweight and obesity is also relevant for this part of the globe. I will focus now on 3 items of the whole complex story of obesity, of the complex puzzle. So first on maternal obesity, linking this presentation to that of Keith. Then I continue with childhood adiposity and multi-organ consequences. And at the end, I focus on some next steps for future research and practice. Of course, we are now discussing this, but we have to realize that the concept that preconception health and preconception care is important to tackle childhood obesity is already acknowledged. We know that. We do know that. It's already part of the ECHO WHO report on ending childhood obesity. So it's not new, but we are still not there. And the question is, of course, why not? What's happening? I focus now on obesity because from our data, I will come back in our study, we do know that maternal obesity is by far the strongest determinant of childhood obesity in Western countries. But the question is, of course, when you look at maternal obesity, what is it? So maternal obesity, maternal weight before pregnancy, and then you have gestational weight gain, so the weight that a woman needs to gain also during their pregnancy. It reflects the nutritional status needed for the fetus, clearly, for the glucose, fatty acids, insulin resistance, of course, is related to that. And then you have the gestational weight gain. And of course, gestational weight gain is needed because there is a fetus, there's a uterus, there's a placenta, so there is weight gain needed. But we do know that it's very difficult to establish what is the correct weight gain during pregnancy, and which is the optimum weight gain also for pregnant women. And gestational weight gain is known to be associated with having a lower educational level, I actually mean higher gestational weight gain, non-Dutch background in our studies, an unhealthy lifestyle, and it also reflects and is associated with higher insulin and glucose concentrations in the mothers, with their fatty acids profiles, and also, of course, also with the cardiovascular risk factors, well-known cardiovascular risk factors. It's also related, maternal obesity at the start of pregnancy and gestational weight gain with preeclampsia and diabetes, gestational diabetes, of course. That was only in the mothers. And we do know from observational studies that maternal obesity is associated with outcomes in the offspring. And here you can see a study published in the BMJ from Rebecca Reynolds in 2016 already, that maternal obesity during pregnancy is associated with premature mortality from cardiovascular events in their offspring. A very big study showing different obesity groups of BMI groups, and clearly a clear association. Of course, having these kind of data, it's always the question, is it really causal, or does it reflect other factors, such as confounding? In our Generation R study in the Netherlands, in Rotterdam, in the city of Rotterdam, which is the second biggest study in the Netherlands, we have the Generation R study. It was established in 2000. It's a prospective cohort study from the early fetal life onwards with detailed measurements. It's not the biggest study in Europe, but we choose to have a study which is big, of course, but also enabled us to have detailed measurements, detailed assessments in all these parents, also fathers, mothers, and their offspring. It's a multi-ethnic population in the city of Rotterdam because half of our population is not Dutch. I will come back on that. And first, for this, I will show results on the associations of maternal obesity with childhood obesity and the metabolic syndrome outcomes. And you can see on this slide the different BMI groups, underweight, overweight, and obesity, and then the odds ratio of having childhood obesity in their offspring. And you can see very clear association, of course adjusted for potential confounders. But you can also see the association of having excessive gestational weight gain, classified by the IOM criteria, with the risk of childhood obesity. And you can see also a similar risk of having overweight during pregnancy. In the other part, you can see similar associations for having a metabolic syndrome phenotype in childhood, so including not only obesity, but also high blood pressure, insulin glucose concentrations, and lipids. And you can see a similar picture. And we took these results forward to a bigger collaboration, a European collaboration, in the EU Child Cohort Network. This was a collaboration, this is actually a collaboration, which actually also Keith and Bert Koletsko are collaborating, bringing all these different cohorts in Europe together, because the challenge with these cohorts is that you have so much data that you're actually not able to use it. So we try to optimize strategies to capitalize on these data that is available in these cohorts. It combines the data of these cohorts, more than 200,000 mothers, actually also the fathers and the children, in Europe, the UK, and Australia, and have a follow-up of the oldest cohorts of 45 years old. And actually, there's now also a strategy to make it bigger, also into non-Western or non-European countries. We use this data set to go further into the story of maternal obesity and gestational weight gain. And first of all, we wanted to explore whether the association of maternal weight with childhood obesity is only there for overweight and obesity, or is present across the full spectrum of BMI. And you can see here 3 lines: the early childhood, the lowest line, then the mid-childhood and late childhood. So it's actually until 5 to 10, and higher than 10 years old. And you can see an association which is present across the full spectrum of maternal BMI, so the association with childhood obesity, and the association becomes stronger when the children become older. That was not known from our own study, but that's why you need bigger numbers. And then we come back on the question, what is the effect of maternal BMI and gestational weight gain on childhood outcomes? And we use these data from all these cohorts to try the optimum combination of pre-pregnancy weight and gestational weight gain. And you can see in the blue figure, you can simply see the numbers of these different combinations. Each square is a combination of numbers of participants in each combination. So the darker the blue, the higher the numbers, the lighter the blue, the lower the numbers. And you can see the total picture is blue, so you have enough numbers to do the analysis in each combination. When you go to the red part of the slide, you can see the risk of having adverse maternal and birth outcomes in the offspring. The darker the red, the higher the risk. And you can see clearly that the higher the pre-pregnancy weight, in combination with the high gestational weight gain, leads to a high risk, extremely high risk of having pregnancy complications or birth complications. And using these data, we try to define the optimal ranges of gestational weight gain, and actually for different BMI categories. Thus far, we only had the IOM criteria, which we also use for previous studies, like just presented. But these were actually not based on real data. So we now try to create better ranges based on real data for different BMI categories: underweight, normal weight, overweight, obesity, and then grades 1 to 3, for your weight gain, actually your weight gain, the optimum weight gain for during gestation. And you can see here that there are differences. Actually, for underweight women, the optimum weight gain is probably around 15 kilograms. For obesity grade 3, our results, our data actually suggest that you should either lose weight or have a weight gain from less than 6 kilograms. This is important, of course, also from clinical practice, at least in our country. Going further into the mechanisms of gestational weight gain and BMI at the start of pregnancy on childhood outcomes, one potential mechanism is, like we always mention for every mechanism, DNA methylation. So we did in a similar combination of cohorts an epigenome-wide methylation analysis, and we identified 86 CPGs or methylation sites affected by maternal BMI during pregnancy. And these were all mostly genes related to metabolism of the child. Going back to our own study, the Generation R study, we specifically were focused on, if you look at gestational weight gain, what is the critical period? So gestational weight gain seems to have kind of effect on the outcomes, independent of maternal BMI at the start of pregnancy. But when is this effect? What is the sensitive/critical period? So we had this occasion for measurements of detailed fat assessments using the DEXA scanner, also MRI of visceral fat, liver steatosis, pericardial fat. And we disentangled the effects of different trimesters of pregnancy on the fat measure outcomes, by using actually residuals in the regression analyses. So we made them independent of each other. And here you can see that the strongest effect estimates are there either for pre-pregnancy weight or first trimester weight. And actually, whereas the mothers have enormous weight gain in second and third trimester, there's hardly any effect on childhood outcomes, fat-related outcomes in our study. So this first trimester of pregnancy or pre-pregnancy seems to be most important for childhood obesity. And to summarize this, the associations are clearly there across the full range of maternal BMI, and they are related to the offspring outcomes, for now focused on childhood obesity. Then the second part of the puzzle I want to discuss is the multi-organ consequence of childhood obesity. So what is the problem of childhood obesity? This is the prevalence in our study. So up to 25% of the children are overweight, different ethnic groups in our study, and about 10% is obese at the age of 10 years. And please realize childhood obesity at the age of 10 years is also a risk factor for cardiovascular mortality many decades later, so it isn't a challenge. But going further into the fat consequences, fat mass consequences, we try to assess whether these ethnic differences in childhood obesity or childhood overweight are also having consequences for more relevant fat mass measures, like visceral fat, of liver steatosis, of total body fat, assessed by DEXA. And you can see here three figures: the total fat BMI, total fat mass relation, BMI android-canoid ratio, waist-hip circumference, and then you can see the BMI and pre-peritoneal fat as proxy for liver steatosis. You can see here, as a main conclusion, that the associations with BMI and these different fat layers differ for different ethnicities. And in the subtitle, it's already mentioned, the Surinamese Hindu group with an Asian background. Actually, these were Indian people moved first from Suriname, and then from Suriname to the Netherlands, because Suriname is an old colony from the Netherlands. They have relatively more fat, total fat and organ fat, with the same BMI. That's why actually we need to have a country-specific or region-specific BMI charge, reference charge, because the consequences for fat layers is not similar across the different countries. Why is this important? It is important because pericardial fat is a very strong predictor of cardiovascular disease in childhood. That's what we measured using the MRI. You can see here a result using this MRI from the cardiac MRI at the age of 10 years. Actually, we did not find a strong effect of pericardial fat, but we do find an effect of higher childhood BMI with larger right and left ventricular size. You can also only study this by MRI, because with an ultrasound you can only study the left part of the cardiac system. But most importantly, lean mass was stronger determinant than fat mass. So in childhood, it seems that fat mass does not strongly determine the cardiac size, but it's more lean mass, which is really different as compared to adults. This is different for non-alcoholic fatty liver disease. So we also assessed liver fat by using this MRI in the Generation R study. Liver fat is really well known, common liver disease, high prevalence, really related to obesity clearly, and the risk of liver failure. And we did find, and this strongly links to the message from Keith, if you look at the red circle, we tried to combine fetal and infant growth patterns. So you can see here 9 groups of fetal and infant growth combinations. First, fetal growth deceleration, so having a low birth rate, leading to a low birth rate, normal growth, and then growth acceleration, let's call it a higher birth rate, and then also the 3 groups of infant growth deceleration, normal, and acceleration. And actually, you can see here that the highest levels of visceral fat and liver fat were observed for those children with fetal growth deceleration, so being small at birth, but then having an infant growth acceleration, so a mismatch in growth, which is a very strong effect estimate, actually. Why is this relevant in childhood already? You can see it here. So the liver fat fraction is related to the odds ratio of cardio-metabolic risk factor combination, let's say clustering of cardiovascular risk factors. You can see a steep increase from the liver fat percentages on the x-axis and then the outcomes on the y-axis. And you can also define non-alcoholic fatty liver disease. And if we do it in our cohort, you can see on the right part of the slide the effect estimate for clustering of cardiovascular risk factors. So very strong effect estimates already at the age of 10 years, which are known to track into adulthood. Further, actually, non-alcoholic fatty liver disease is not a very appropriate name for the challenge, because rather than non-alcoholic fatty liver disease, you should talk about metabolic-associated fatty liver disease. And that's what we actually use in our study also. And here you can see the metabolic-associated fatty liver disease, which is defined as having more than 2% of liver fat in combination with any cardiovascular risk factor, is related I will not go into detail of these 6 outcomes, to different cardiovascular outcomes. So it does matter if you have increased liver fat, whether you have the metabolic-associated fatty liver disease or the non-metabolic-associated liver disease in relation to your cardiovascular outcomes. I will skip this one because of time. We also try to disentangle the metabolic effects of BMI in childhood, obesity, with their metabolic profiles. So we used, together with Bert Koletsko, a metabolomics approach. And this study actually showed at the age of 10 years that an adverse childhood body fat profile was already associated with metabolic alterations, with particularly amino acid, phospholipids, carnitines. This already is, of course, suggesting for different metabolic adaptations, but we do not know the consequences yet on the longer term. We need further follow-up studies. But what we tried with these data is, could we predict in a better way the risk of a metabolic unhealthy phenotype with a short-term follow-up in this stage, because we need children to become older, of the metabolic syndrome. And here you can see different prediction models. First BMI, then we add total body fat, visceral fat, body composition, because the combination of BMI, fat mass, and visceral fat, and then the metabolic markers. I will not go into detail, but if you look at the first model, the BMI model, an area under the curve of 0.59, and then the metabolic profile model, you go up to 0.9, which is a steep increase. Of course, it makes a big difference, but we really need further studies for the longer-term follow-up to establish whether this has also a clinical implication. The last slide for the childhood consequences is focused on a whole other outcome, which is brain development. Because we did the total body MRI in our study, we also assessed whether overweight and obesity also affects brain development. And here you can see that actually underweight, so not specifically overweight, underweight does affect volumes of your brain development, so gray matter, white matter, but also your diffusion or connection actually measures, which are affected by body fat. So to summarize, adiposity and multi-organ consequences. Childhood BMI and body fat measures differ between ethnic groups. That is really important to realize and also to take forward when you see these children. Growth and BMI are both associated with total body fat, but also organ fat, pericardial fat, liver fat, and their metabolic consequences. And they are related to cardiometabolic profiles, but also other non-cardiometabolic outcomes, including brain development. Then very briefly, because I see the time is up, I go to the next steps actually that we are taking, and I think that these are important for research and practice. For this reason, we started the Generation R Next study. The Generation R Next study is not a repetition of what we already did. So it's a new study focused on the preconception period and the embryonic development, because we saw that looking at all the data from our bigger Generation R study, you need to look in an earlier stage of life. So it's not about fetal life, but actually it is about how women enter pregnancy. So that's why we focus on the preconception period and subsequently also on the embryonic development, because already a lot is happening in this first 8 weeks of life. And we have a population intervention approach. This study, also population-based, is now actually complete already for the observational part, with 3,700 women, and the intervention part is actually now ongoing, and we aim to include in total 1,750 women and their partners for the intervention. We are being randomized. And we have detailed measurements again, of course, like we had in the Generation R study. This study has different focus areas, and for the intervention study, I like to express that it's not focused on women, because it's not blaming women, it's on couples. So also the partners are involved, because you need the partners if you wish to improve lifestyle of women for pregnancy. That's already a reason to include also their partners, but also we are quite sure that also their partners have long-term effects on the offspring. The only thing is we don't need them because they're not studied so frequently. And this is actually the first study coming from this new preconception population-based cohort study, focused on BMI in women and the risk of time to pregnancy and the risk of miscarriage. Actually not focused on women, but women and their partners. And we actually observed that BMI outside the normal range in women and men is associated with a higher risk of a longer time to pregnancy, so actually subfertility. We also observed that overweight and obesity in women is a higher risk, leads to a higher risk, strongly higher risk of miscarriage. So the main message for this paper was actually that optimizing BMI, not only in women but also in their men, is important to give their offspring a better chance in the beginning of pregnancy. And now, just to illustrate you what we are doing with this new study, we collect early ultrasounds, and to be honest, that's also the main reason why these women participate in the study, because they have very nice fetal ultrasounds. And we analyze them with 3D virtual reality approaches. This is actually a picture of an embryo at 8 weeks, and this is what we do with it in the virtual reality approach. We try to measure early organ development. You can see the heart and the lungs in this way, but we go further into the whole body. And of course, results are forthcoming in the upcoming years. And to end now, to summarize, what is the main message to take home from this discussion? I think clearly there's a double burden of underweight and obesity around the globe, and also in this region of the globe. This is important to realize, and I think if you look at the increase in obesity, probably the part of obesity in the upcoming years will become much bigger. Subsequently, it's important to realize that pre-pregnancy and early pregnancy are the most important risk factors to start with a healthy weight trajectory across the life course. Population-based intervention studies are needed, and they don't need to be so complex. Please realize that in our population, maternal age, BMI, stress exposure are the most important risk factors for childhood obesity. So no complex designs. If you can address these kind of exposure already, which are already complex to address, of course, you will probably achieve an enormous result. And of course, we all have to realize that tackling childhood obesity and its consequences is the responsibility of not only pediatricians, but also obstetricians, all other healthcare workers involved in pregnancy and childhood. And don't forget the fathers in the story. So thank you, and sorry for being a little bit longer.